Hello and welcome back. Okay, in the last video things were going a bit wrong, and so it's time to do a bit of troubleshooting and see if we can get it to run stably again. So I have been kind of playing around and having a look. If you remember, this chip here is a power monitor and it will hold the reset line if it sees the power level has dropped. So I plug the power in, it flashes on briefly, but I have noticed if I move the power around and put it in elsewhere, the reset line stays on, and that implies that the voltage level that gets as far as this chip has dropped a bit far. So it's going off and on a bit there. So that implies that between here and here we've got a voltage drop that's kind of fluctuating a little bit. Let's see if we can put some numbers on that. Actually, firstly, what are we getting off the connector on its own? 5.05, so about 5 volts. So we're getting about 4.8 in the strip directly adjoining the connector. So the power supply I've got is kind of okay, but it's obviously not perfect. Bench power supply might help us out. Okay, it's 4.12 down in this corner. Okay, so we've got 3.7 over here. Now with these kind of drops, I'm almost surprised we haven't been seeing more problems. I don't know for a fact that power is the source of all of the problems we've been seeing, but I'd be surprised if it wasn't a problem. So the power to over here is coming from, I mean, if you think about the number of jumps we've got, so the power going in here, it has this junction, then here, this junction, this one, this one, this one, this one, this one, and then it jumps over to here. So I'm going to see what I can do about distributing power better. Right, I've got a mini USB here I'm prepared to sacrifice. Let's see what it's got inside. That's how I made my original power cable, but this was a random cheap one. Okay, I'm guessing this external wire is ground. And this power line does look a lot stronger than the data lines, which was not the case in that one. So I purchased this as a fast charge capable cable, which I was hoping meant it could take a bit more current. Yes, there is a lot more conductor in here. It's a good start. Thread various bits of heat shrink on here. I've got some of this cable. This is red and black, 2 cores, and what I want to do is get a power distribution point up there and then run separate cables out, a few in each direction. I'm going to run it to every single power strip, but if I say bring 3 down here, 3 down here, a couple over here, and then maybe bring separate ones out to these boards, it'll end up looking like a cat o' nine tails, but I think we'll get far lower resistance power distribution to all the locations on here. Okay, so I have soldered this up. Hopefully this is going to help us out. If nothing else, this is going to eliminate power issues from the investigation, but all the time we've got the kind of power issues that we're seeing, I won't be able to get it out of my head. The wiring points down here aren't actually ones I can easily plug one of these DuPont cables into. I was annoyed that the sleeve on this stuff is so thick, but I'd rather put up than have a build that doesn't work. That's still not ticking right, but we do have much nicer voltages. Okay, so that's very consistently wrong. If I reset it and clock once, I get an increment of 2. So increment is coming from here. Let's look at everything that could possibly be going wrong there. This is a 74LS139. It's got 4.98 volts on the power input. That's excellent. Now, that inverted clock comes from over here and it goes into 5 chips. These are LS chips, so the fan out into them should max out at 10. But things did start going weird when we added this chip. I'm just going to pull the clock line from it. Right, we're still getting the double clock, so it wasn't that. One thing I'm very unsure of is I keep putting LEDs on stuff and I don't know how much drain they make compared to like a TTL input. I could take this clock out and get it from somewhere else. I've got an inverted clock line over here. Still double clock. We've got the line down here that would switch the clocking from program counter to the return address. If I change it from low to high, we're still getting similar weird output there. So that means the signal's coming from over here somewhere and it's not something that's gone wrong with this board. Just double checking it wasn't the capacitor here. Slightly suspicious of the clock circuit now. Let's drive it directly from the clock line and see what happens. That's getting a single step. It's the second time we've seen weird behaviour on this counter. I don't trust this counter board anymore. Yeah, the others are working fine and this one is responding badly. Okay, that's the same inverted clock line we're passing into the chip. Ah, that's interesting. I took this connector and moved it along one so I could stick the program counter in there, but of course that means the current signal that should be going to the program counter is going into the return address. So we can see the difference in response there. This is pointing very heavily that this chip is misbehaving. Okay, both inputs should be at ground. Pull it down directly just to eliminate that. The counter chips here are very, very quick. I think they're capable of 40 megahertz counting. So the amount of error on that line to create the extra clock is very, very low. Right, I don't have any spares, but there is another one next to it. This is the one we use to select the ALU inputs. It's simply not behaving correctly. So the increment light comes on here, but it doesn't increment. Right, I'm going to take my mind away from the problem for a bit. Let's take a look at this board. There's a bridge connector there. That looks like the pin is bent up. Stunned at the amount of dust that has accumulated on these things since I made them. As well as an oscilloscope, what I need is a clean room. Right, this is not correct output. This is. So the chip in this location produces correct outputs, but over here it produces weird outputs. That's producing outputs that look more or less right, but we're getting our error. Could it be the inputs in this location? I mean, either way, this chip is not behaving how we expect it to, but it was. So that either means we're expecting the wrong thing of it, or the chip's dodgy, or the wiring around it is dodgy. Okay, let's look at this one again. Right, looks like we fixed that, at least the increment part of it. Alternate theory. These LEDs really are a problem. Well, that's only just worked, hasn't it? Right, this is a much higher value resistor. Okay, this is starting to make some sense. So these are increments and those are decrements. I reckon those LEDs are slightly higher current and they're just pulling a bit too much. Now remember, when we go to increment or decrement, we're actually driving two LEDs now, because we've got an LED on the bus drive circuit and we've got an LED on the input to the register. So here is the increment when it gets up here and here, then we get an increment here and a decrement here, decrement here, then here. We have a winner. Okay, let's have a look at this a bit more. Now, we ran into the problem before when we were copying between registers. So let's test out our transfer bus control logic here. So I want to take SI, so it's going to be addressed 4. I want to load it into this register, which we think we fixed. Okay, so we've still got one LED that hasn't come out. No, two LEDs that haven't come on correctly there. Let's try putting it down here. Okay, so that's all correct. Actually, I had a use for this control line that prevents instruction fetch. So, okay, we've got that completely fixed now. So, assert this one to the bus, and I want to load it in this one. That's good. And this one LED is dubious, or at least one bit is wrong. Is that because this LED is wired wrong, or I'm sure we tested them all? The one at the bottom, that appears to have everything. Let's load it into the program counter. It's essentially a jump instruction. Okay, so I'm still suspicious of this board. Okay, the signal is on the bus. Right, so I've now swapped the suspicious board around with the one at the bottom. So this is the one we're worried about. So allow fetch. Make it do stuff for a while. Stop this fetch. Okay, so this has loaded all its bits. Didn't mean to leave that loading, but this should initiate a load here. Same problem, same bit. Believe that pin. So we had a similar problem on the pin at the end, but it didn't seem to be contributing to any issues. I think maybe this chip got knocked at some point and a couple of its pins were stuck in the air slightly. Right, that's our code working correctly still. So now I'm going to prevent fetch. We're already asserting this one to the bus. Let's tell this one to read, which is the one that we believe works. And then the one at the bottom to read. Yes! So not only have we got the board back into operational state, we have fixed the issue in the new circuit we had where things weren't behaving as expected. Oh, that's cool. Allow fetch. There it goes. Right, just want to see one thing actually. I'm going to tell this one at the bottom to assert to the bus. So set that to 5. I'm going to tell our previously troublesome register to load every clock. Oh, hang on. Now we've got another bit that's not loading. But the problem with this one was that the output from this chip wasn't actually wired properly. Oh no, hang on. This one was the good one that we tested before. So this I did this to demonstrate the fact that the value we transfer is the value from the cycle before. So when I clock it again, it will copy that up. But we're not getting that bit. So that's being asserted to the bus. Let's kill fetch again. Let's tell this one to load it. Let's load that to there. So same thing has happened, we haven't got that bit. Tell this to assert, and that gets the whole thing. So on this one, we've got bit 5, which is the second bit on this chip, isn't getting asserted back to the transfer bus. Now, it is coming out onto the LED, so that's going to be either this pin or this pin. What's the betting those are dodgy? It doesn't look like any aren't making contact, but this does have pins that are higher off the board than normal. The weird flickering there was me telling this register to load from the bus without telling anything to assert to the bus. So it effectively just had random inputs. Okay, well, we understand it. There is a 1-bit error on this board somewhere. That means it's not getting out. But everything else we've looked at is working correct. Okay, it's the next evening for me. I've been thinking about this quite a bit during the day. Let's check where we are. That is all still working, that's excellent. It's really good to see actually. So we had the problem loading some bits in this register. Okay, so I'm going to switch this to constant load mode, hardwire that control bit. So it's just loading every byte in memory up as a constant, but it's basically just going to increment this without doing anything else that interferes with what we're seeing. So assert the program counter to the bus. And load that up here. Right, so that's the error. So that bit's not showing up, but both of those next two bits show up at the same time. Now, I've checked the pins here very carefully a couple of times now, and I don't see a problem. Now let's try a different register. Oh, this is exhibiting the same problem. Same there. Okay, so this isn't a board-specific issue. This could be a mistake on the board, or it could be a mistake on the back plane. And if it's on the board, it could be with the asserting to the bus, or it could be a problem with loading back from it. I don't think you can see that here, but I do have a connector at the bottom that I can plug cables into. So what I want is to get a view of what's on the bus. Okay, so we're seeing the problem actually on the bus, so this is a problem with what's being asserted. I need to take them all off. We don't have a bridge connection along there anywhere. But a bridge on this chip on any of the boards could cause that effect. Or on this chip. I mean, that chip that I've just seen a bridge on. That could be it. I don't know where all this fluff comes from. I cannot see it with the naked eye. I really should have got my anti-static mat out to do this. Yes, that's working. Part of me wants to wait and see it count all the way up to 65,535, but that's each new bit takes twice as long to test as the one before. And that's actually going to take a while. I can make the clock go really fast like that. Actually, that is pretty much giving us the test we wanted. I'm pretty confident that's working. There could still be hidden issues that we haven't uncovered, but right now we've solved every issue we knew about and it's working stably. Stop the clock, reset everything, switch the constant load back into its proper data line. And there's our basic test program running quite happily, scrolling this value through all 4 general purpose registers. I'm really chuffed with that. When I started to see all the problems, I was very worried it wasn't going to work. But that's very rewarding to sit there, work through all the problems and solve them. I'm very happy. Next video on the CPU build, we're going to be actually implementing these back into the control unit, so then we can do the 16-bit moves. In theory, this is what we need to implement jump instructions as well, but that may well wait until we've got the transfer register, because at the moment the only way we'd have to construct a jump address is by incrementing and decrementing values. Although actually, yeah, we could guarantee that a register will be 0 and use it to jump back to the start, so we're not dealing with completely arbitrary 256 byte loops. So that's probably worth doing, actually. Okay, so this has been very productive, and I hope people have found this interesting. And well, thanks for watching. Goodbye.